Welcome back everyone to another video. Now in this one we'll be finally taking a look at a simple Blinky program to just test out the GPIO on the HiKey960. We do have Linux SFS GPIO that work very well. So today again we'll be going ahead and looking at it and see how that works. Now I was planning on doing multiple LEDs, but I actually ended up doing only one, and we'll talk about it later when it comes out. But for now, let's go ahead and take a look at the script. So it is a simple sh script, and this is how it looks like. So the first comment below the bin bash line is just to be run once, and I have already run it, so there's no point in executing it again. Hence it is commented out. It just exports the GPIO pin number 493, which is the Linux GPIO pin number for GPIO 21, that is on pin number 34 on the 96 boards header for the HiKey960. So that is the first pin that we export, that creates the GPIO 493 device folder, and from there next line we set the direction as out, start a loop, and then alternate between on and off by setting the value to 1 and 0 and sleeping for a second in between. So pretty nominal stuff, nothing out of the ordinary. Let's go ahead and run it, and this is how it looks like. Now you would be noticing that the LED is not very bright, and this is one of the reasons why I actually ended up doing only one LED. The other two LEDs are green LEDs, and they do draw a bit more current and require a bit more voltage than the red one. The red one is a bit sensitive. It does run very well on low voltages or less current, and the HiKey960 cannot provide a lot of voltage. It only works at 1.8 volts. It's limited by current a lot. Now if you are go ahead and create a project, I would recommend using a mezzanine board that would allow you to switch between 5 volts and 3.3 volts and 1.8 volt GPIO voltage outputs, so you can work on that. And that actually makes things very easy. 1.8 volts, you won't find many devices that work directly off of it. Apart from that, so if you're wondering how come the Raspberry Pi 3 has a 3 volt output, and that is because the SoC is not that powerful. It's an old design and it works on 3.3 volts, although the cores inside of it still work at 1.2 or 1.8 volts. Now on as a silicon gets more complicated, the voltages needs to be dropped, and the current rating also needs to be dropped. Otherwise electrons start skipping and heat starts building up a lot. So if it's built on a smaller manufacturing node, like for example 20 nanometers or 14 nanometers, you would actually not have a lot of voltage coming out of the GPIO pins. Now in case of the upboard, which also has a 1.3 volt logic for its Intel Atom processor, it actually has a dedicated FPGA inbuilt on the board to control the GPIO pins. But the 96 boards certification thingy requires the GPIOs to be directly out of the SoC, and that's what we have here. The GPIOs are running at 1.8 volts instead of something like 1.3 or 5 volts that is available in many other FPGAs or something like Arduino. So not a lot of LED right now. I couldn't even get my buttons to work because they were hooked up to a 10K resistor, which is required for safety to work with something like a Raspberry Pi or an upboard or an Arduino, and but the 10K resistor just doesn't allow the voltage to rise up that high to be detected by the GPIO input pins, and hence the button does not work. For me right now, again I will have to rebuild or do something on the breadboard to get that to work. So for now, this is how the setup looks like. Simple red LED on and off. Apart from that, not much. Again, a huge shout out to forum members of the 96 board who helped me out with the pin numbering and all of that stuff. Good job there. And if we close that out, we should have that stopped. So again, I am running on the same open embedded build. We are still waiting on a full Debian build, and but the GPIO works. All of the GPIO pins work. There's none left behind. Like in the harassment, only two work at that moment. On the HiKey960, all of them are available to use. It's just a matter of figuring out the Linux GPIO number and exporting the correct one. So that is about it for today. I'll keep it short. Thank you so much for watching and have a great day.